Please welcome Raquel Urtasun, founder and CEO of Waabi, who's building the next generation of autonomous trucking, and Sanja Fidler, VP of AI Research at NVIDIA, who was handpicked by Jensen to head this lab, both co-founders of the Vector Institute, prior faculty at U of T, and at the forefront of AI advancement here in our backyard. And they're joined by Mike Murchison, CEO and co-founder of Ada, a conversational AI leader right here at home. Welcome.
Welcome, everyone. We are super excited today to talk about two things. We're going to talk about the frontier of AI, how AI is entering the physical world, and we're also going to talk about how Toronto gives AI companies an edge. You guys ready to get into it?
Yeah.
All right, let's do it. Okay, well, Sanja, let's start with you. As we just heard from Satish, Jensen selected you and Toronto to lead the spatial intelligence lab for NVIDIA. Why don't you walk us through when that happened and how's it going? I don't think much of the audience actually appreciates just how significant this lab is and that it's right here in Toronto.
Yeah, can you hear me? Hi, everyone. Thanks for inviting me. I think I'm going to start where probably everything started, which is AlexNet. Everyone knows AlexNet, right? That was 2012. And it started with a very important problem, computer vision, that many industries care about, right? There was a major breakthrough in performance. And how that was achieved is basically three visionaries coming together in like this one breakthrough. One was data, for machine learning, you need data. So Fei-Fei Li at Stanford, kind of saw we need to scale data. That's going to be the future. That was the ImageNet data set. Then was model, which was neural nets. Jeff Hinton and his students, he was a believer for decades, right? Simple ideas, right? Most scalable. They might have worked. And then there was CUDA, right? So the neural nets plus data met CUDA with chip. And that was Jensen's vision. He released CUDA in 2006. By basically opening up the parallelism on the GPU to general computing. That was his vision at the time. Or at the time, the chips were mainly used to accelerate graphics, and this basically opened up to just general computing. And at the time, it was quite a departure, actually, from kind of the core business of NVIDIA. So this was really kind of like a visionary bet. And what I heard from someone that was at NVIDIA at the time is that he said, one day, there's going to be, a grad student or a researcher that's going to use this to do something really amazing that we cannot even think about today, right? And all that kind of came together with AlexNet, and then really changed the world, right? Everyone started investing in AI. So it was very clear that, Toronto has a lot of talent, right? So I think NVIDIA kind of had an eye of, opening a lab here. Yeah. I met Jensen at a CVPR. This was a major conference in computer in 2017 at a party, and we hit it off. And that's basically how we started.
I think that's a really important point in Toronto's AI history. AlexNet. I think it's one that everyone in the audience should understand because it is a catalyst for very much what we're experiencing today. And one of those companies that has been extremely successful that we might view as having been catalyzed in part indirectly by AlexNet is, of course, Waabi. Now, Raquel, you are a U of T professor. You were the chief scientist at Uber ATG, where you ran the autonomy division, and you've since started Waabi. Why don't you just give everyone an understanding of that journey and where Waabi is today?
Yeah, and I will echo and I will start where Sanja kind of left it off, which is amazing talent, research, ecosystem here in Toronto that, I think attracted many of us, including us to, we came here as academics, reason being that the technology wasn't yet ready to make that leap in terms of really transforming the world. So there was a lot to do in the development of algorithms, etc. And then it was the moment to kind of join industry and being able to be in a kind of top tech company that set really significant labs in Toronto was actually very, very important in order to really cultivate an ecosystem where, everybody was very excited to come here, to stay here versus, okay, there is no NVIDIA, there is no Uber, there is no Google, therefore I'm going to go to the Silicon Valley. So that kind of created that ecosystem. And then what you see now is many of us, Aidan was here before, right, that
left the big tech labs to then start our own venture, right? And it's been amazing to see kind of like now, full Canadian companies really making tremendous impact in the world. And in the case of Waabi, 4 years ago, I saw a tremendous opportunity to be a disruptor for the self-driving industry. Just for context, if you look at robotaxis, $5 trillion markets. If you look at self-driving trucks, $4 trillion market. These are massive industries with, a handful of competitors on them. And what really bring us to that moment was this idea that instead of trying to do what everybody was doing, these very honey-eater approaches that I didn't think it will get us there, following on what Sanja said is, well, we need to reinvent the way that we think about data. And we need to reinvent the way that we think about autonomy by thinking about, what AI can really do for us. So it was very contrarian at the time. With Waabi, we started a company on end-to-end autonomous driving. This is before, Tesla or anybody was doing anything like this. And also we bet in terms of we will never observe enough data. Therefore, we're going to build a matrix for self-driving. What is this? A simulator that is so high fidelity that you cannot make the difference between the real world and simulation. And therefore, you solve the data problem. The rest is history. 4 years in, we are about to deploy with no human on board. We have been doing, commercial operations in the US for a few years with, top, Fortune 500 companies. And it's really exciting to be doing this from here, from Toronto.
Yeah, it's amazing. I mean, I think a pretty bold bet to be when you did it to rely on simulated data or world data from a simulated environment and not real world road data to train the Waabi driver. And it's amazing to see that paying off. Now, congrats on the Volvo partnership earlier this year. Let's talk a little bit let's lay the foundation for what spatial intelligence actually is, because I want all the founders in the room to walk away with some understanding of, again, the frontier of AI and some of the opportunities that Toronto's creating right here for us. So Sanja, maybe you could walk us through what is spatial intelligence and why is it so significant?
Yeah, so everyone knows right now large language models, right? Because this is the biggest success these days you see with ChatGPT and alike, right? However, we all live in a 3D world, right? We're sitting here in a 3D world. That's the physical world, the 3D world. And many industries actually rely on processing 3D data as opposed to just text data, 3D tokens as opposed to text tokens. For example, robotics, right? Autonomous driving, general robotics, warehouse robotics. They all need to operate and navigate and do things in a 3D world. So you need intelligence that can do that, perceive the world, create digital twins and so on. Raquel can talk a lot about that later on. Other fields, for example, engineering, architecture, before you actually build a house, build a building, you need to simulate it, right? All the physics elements and really optimize it to create, a really good environment, a bridge or whatnot. Gaming, a lot of games are in 3D, right? And they're going to have more and more AI in it, right? Where all the agents are going to be operating maybe with AI rather than just scripted behaviors. Film, a lot of movies are in 3D. We are 3D, so healthcare, need to actually analyze us in 3D. So basically, there's just so much I could keep going, right? So spatial intelligence is really trying to tackle 3D data. And it starts with a bunch of things, right? One is just a really good infrastructure, right? Such that now I go to another dimension. I go from 2D images into 3D. And that basically faces one of the hardest computational problems, right? An added dimension, right? There's just so much resolution here, large space, but at the same time, I can tell there's something on that shoe, which is really precise, right? So you need, frameworks that can do MLOps, so AI, on really efficient 3D data structure, right? And leverage the fact that it's sparse, and most of the space is actually empty. Right, and that kind of the enabling infrastructure so that people can kind of build their AI on top of that. And then there's different core areas of research that we need to invest in, right? So everything that you're doing in 2D, now you want to do in 3D, right? So generate 3D content, generate environments, understand environments, what's going on, right? Create digital twins, right? For different industries. So there's a lot of research that needs to be done there, and it's really kind of the next frontier where all this is going. Yeah.
Well, Waabi represents one of the use cases of spatial intelligence. Raquel, could you walk us through, like, it's pretty exciting to hear your vision of Waabi, not only as an autonomous driving business, but as a spatial intelligence company. Mm-hmm. Could you speak a little bit about the maybe subsequent use cases after you roll out or the leader in autonomous driving? What happens next?
Yeah. So all our technology, both the autonomy, the brain of the robot, as well as the simulator, is built so that we can actually very easily do other use cases in the future, and I would say in the near future. I will tease that here. And this can be, right now we do self-driving trucks, Class 8 trucks, the biggest, kind of trucks that you can see, out there in the world. But you can do things like humanoid robots. You can do drones. You can do warehouse robotics. You can do, robots that pick up stuff and whatnot, right? All these different things are, to Sanja's point before, they need to understand the 3D world. They need to interact with it, including humans, which is, one of the main difficulties, for any robot is how do you do that in a safe manner, right? So it's very exciting to see kind of the whole vision of Waabi is, yes, start with trucks, right? And we talk about this, it's a massive opportunity, but this is just the beginning of, you're going to see robots everywhere. And, there are going to be many of them Waabi branded, which is, a very, very, I would say, exciting moment. But as you deploy physical AI technology in the real world, there is actually a few things that you need to take into account that are a little bit different than the digital world and makes the task actually more complex. So let me walk you through the, 3 things in particular.
Yeah, do.
The first one is, well, these systems need to really be able to handle all the scenarios, all things that you're going to see in the real world, regardless of whether you have them on your training data. So they need to be able to generalize to the unknown to anything, right? Why is this? Because, well, they're physical and they interact with us. So there is tremendous consequences if they actually do the wrong thing, right? So that's actually a category that is not about memorization and then, prompting multiple times. You don't have that luxury. It has to work all the time. The second one is that you have to be, your system has to be very, very efficient. You cannot just send it to the cloud and say, okay, give me an answer. Well, you're driving in the real world. There's the safety critical situations happening all the time. In a fraction of the second, you need to actually do, the right maneuver, all the time in these systems, right? So you need to be, embedded in the vehicle, right? Not rely on any connectivity, and be very safe. And the last bit is that, well, we talk about consequences, we talk about safety, but it's not enough to be safe. And, people oftentimes are confused about what do you mean, Raquel? So not only you need to be safe, you need to be able to prove that you are safe. Because prior to deployment, you need to show, this is my safety case. This is why we are safer than humans. This is why it's a great idea to actually deploy our trucks, on public roads and save many lives, right? And that actually, kind of puts the frontier in terms of what you need to develop to the next level compared to the digital world where, you can deploy things and safety sometimes, is an afterthought. Here it has to be at the core of everything that you build. And that kind of guided the type of approach that we did with simulation first, right, as we talk about, because you will never observe, enough data. If you look at driving on highways, death on the road when a human is driving is every 100 million miles, right? It would take many, many lives to get there. And nobody has the fleet sizes to actually prove safety, right? So it was mandatory to be able to do something different that actually breaks the statistics with no consequences, right? And the same in terms of the stack was, in a way that you can verify the system while being end-to-end. It was a big, I would say, step forward in terms of what the industry was. So it's, coming back to the point about, this panel is about research, innovation, and delivering in the real world, right? These are examples where, you really need to push to the next, the next level, and you need to do fundamental research, but for something that you can really deploy. And there is a very, very interesting kind of ways to do that. And NVIDIA and Waabi being, 2 pioneer companies in that, being able to combine these 2 things to really have tremendous impact in the world.
Yeah, and just to kind of echo what Raquel is saying, right? So when we watch these computer graphics movies, right? When the recipient is a human, it needs to look beautiful. It needs to look catchy, right? So it kind of captures our imagination. When the recipient is a robot, it needs to be boring. It needs to be like the real world, it needs to be physically accurate. And simulating the world is extremely hard, right? Imagine a robot making you dinner, right? Breaking an egg, there's always, I'm a bad cook, so fire happens from time to time, right? And those are like a different physics phenomena that even interact with each other. Seems easy to you guys, but it's actually extremely hard. And, like Raquel said, that's still the frontier. When we build these robots, we need to keep advancing on the physical realism of these simulations, as well as kind of the coverage of everything that can happen in the world.
It's amazing to think about how much is unlocked by proper simulation. Like there's a lot of software founders in the room who, are building applications, and they have their own eval suites, and they have a window into, I think, what simulation looks like, with language. When we think about simulation in the physical world, it's pretty amazing to think about the humanoid robots that we're all going to have in our own homes. Like those are going to be tested and safe in the equivalent of a Waabi world, where they won't reach our home until they've gone through hundreds of thousands of hours of training virtually. Completely fascinating. What are some of the hardest problems that need to be solved from when it comes to transferring sim to real world? What are the edges of that right now? Either of you want to speak to that?
Raquel has probably the most experience in that.
Yeah, go for it, Raquel.
Yeah. So, if you look at, simulation systems that, were available in the industry when we started with this vision of, simulation first, there was a big, what is called domain gap, which means that, when you test the system in simulation and you try to expose it to similar things in the real world, the system reacts or acts very, very differently. Right, because that simulation systems were in high fidelity. They might look cool, but these driving systems or robotic systems that are based on AI, the AI system is actually pretty clever, and very quickly can say, no, this is simulation, right? You're not going to fool me. There was a lot of work that needed to be done in terms of kind of pushing Gen AI to the next level to build simulation systems that were scalable, diverse, controllable. Simulation systems with the level of realism was such that was the same as reality.
Meaning the AI, one of the problems solved was the AI was aware that it was a simulation.
Yeah, it would behave very differently. It was aware that this is a different environment, right? And then even if you use, simulation for training, it didn't really matter that much in the real world unless you had very little data. For example, if you emergency vehicles or things like this that you very rarely see in the world. So we needed to really redefine simulation, right? And build a simulation system that was very, very different from anything that was available out there. And a few months ago, we actually put a white paper out showing that how you can actually measure realism, so that for robots, whether it's driving or acting in simulation is the same as the real world. And then we showcase that basically the domain gap of Waabi world is basically zero, which means that now you have the ultimate way to generate, all possible data, and you have the ultimate way to also assess the safety of your system in a way that you can expose it to accidents, to safety critical things, to very rare events, things that there is no way, that you could do it beforehand, right? And it's been amazing to see, and it's the ultimate also, for example, driving test, for anybody in the industry. It's something that we're talking to regulators about, right? And, Canada wants to lead in safety and AI safety, and this is, simulation is an area where Canada has, some of the best research on the, and simulation systems out there. So it's very exciting to see, kind of pushing that to the next level.
It's fascinating. Right now, we think a lot about it inside ADA. If you have the best evals, you have the best language AI. It seems to be the case that if you have the best simulation, you're going to have the best physical AI applications ahead. I think that's very, very compelling. Let's talk about the pace of research, because I think a lot of folks in the room right now are very much trying to keep up with the torrid pace of research. This is a pretty compelling time right now to be building, in part because research feels to be quite a bit ahead of its application in many ways. Sanja, you're someone who's pushing the pace of this research, so thank you very much. What advice would you have what advice would you give to builders who are downstream of what's coming out of your lab?
Seems like I'm the bad person here in this.
No, we appreciate it.
It feels like there's high pace right now. No one, okay, so they disagree with you. Actually, like the game has also changed for AI research a little bit, right? Because we used to do projects that were, 1, 2, 3 people, right? And you were perfectly successful getting your idea and implementing it and showing something really great, right? And there was way few people working on that globally, right? So there was even less competition if you think about it. These days, the bar is like so much higher, right? Even for research, if you're pushing innovation, it's just like completely different atmosphere, right? So even in research these days, we do many people working on the same project. You need to build the right infrastructure, collect the right data, curate that data, build the infrastructure for training these large models, kind of this model data flywheel to keep improving the models. So even research these days is like, a big team working on it, sometimes even cross-team collaborations, which is kind of similar to building a product in some sense. You need to make a bet, right? You don't have infinite amount of people, so you need to make a bet about, what you research, what's going to be the focus of that research. So I would say like we're all kind of in the same boat, right? We all see this high pace happening around us. I would say that like my advice here would really be to nurture deep expertise inside and just be aware of what's happening, right? What does that mean, right? So there's going to be related technology coming out all the time, like really all the time, all right? And sometimes it's hype. Sometimes it's a real threat to you, and you might actually want to pivot a little bit, right? Oftentimes, or I would say most oftentimes, it's actually an opportunity, right? It's an actual opportunity, and you have the domain knowledge, you maybe have users, the ecosystem, the infrastructure, that really puts you kind of at the forefront of that. So you should just kind of leverage the technology to build your product better. Like a really great example of that is actually, I read a couple of months ago on Ilya Sutskever. He was a chief scientist on OpenAI, right? They built the ChatGPT. Was talking about the moment where Transformers came out. It was called Attention is All You Need. But actually that paper didn't get much attention for what it should deserve. So not a lot of people kind of jump on it. And he was saying they literally switched the next day. Right, they saw the opportunity to switch the next day. And that can only be done if you have deep expertise and really understand kind of the opportunity of the technology. So, there is high pace, but my advice is really kind of to leverage that rather than be afraid of that.
Fascinating. Yeah, nurturing expertise and then actually proving the difference between what is hype and what is real. How do you do that at Waabi, Raquel?
Yeah, so we'll start by saying that we also have seen a shift in terms of research. It used to be very academic focused, right, where the major breakthroughs will happen there, and then you will see, industry maybe attending conferences, having interns, and kind of trying to pull that and bring it to production, right? That model is very, very different in the world that we live today, where a lot of the innovation is happening first in companies as well.
Right.
And there is a few reasons for this. Sanja touched upon the fact that for some of this research in large language models, for example, you need massive compute resources, right? So that's actually pretty hard to do from an academic setting. In the case of physical AI, you need robots, and you need to be able to build the entire system together with the AI and, simulation and all of the other things. So you actually cannot do it without, just a bunch of grad students, right? So you end up spending most of the time, kind of like doing little things that do not enable you to really understand what are the real problems that you need to solve that really going to move the needle versus the ones that can be solved already by engineering. So what we've seen is a shift in terms of, I would say, research, but also education. Something that is maybe less known is that both of us, are professors at the University of Toronto still, despite, being many years in industry. We really care about educating the next generation of talent, particularly the local talent here. And, our grad students, which we have quite a few, right, are actually fully embedded in our labs in the companies, right? And this actually provides a tremendous opportunity for them to really understand what is cutting edge research with, all the resources, with, really understanding, as I mentioned before, what are the problems that you really need to focus and solve. And I think that this is a model that we will see more and more as, this deployment, this scale, is this continue to happen, etc. And I think we should just kind of like reimagine, reinvent the way that we educate, the way that we do research, and the way that we deploy that research.
That's fascinating. Yeah.
I just want to make a point here because this is a really good point. So U of T allows students to actually be embedded in industry, like Raquel is saying, right? They're in Waabi, they're at NVIDIA, if they choose to do so. Obviously, not one is being forced. And I don't think anywhere in the world this is actually the case. So many of my colleagues in the US or even Europe are jealous and say, how did you manage to do that? And it's a great opportunity both for students, right? Because more resources, they actually see what's important in the real world. And now is the time to build stuff that works, right? Many more colleagues they can work with, right? More engineering support so you can build and focus more on the innovation. So for the students, it's really like a fantastic environment, right? And we also benefit because you get all these like greatest minds, right, to actually join us and work with us. So it's like a win-win. And I think Canada is really at the forefront of this kind of like new collaboration system.
Yeah, so Mary Keller, who was the previous president of UFT, just retired, right, was a visionary in terms of, understanding that this is the future of education for certain fields, like, like AI, physical AI, etc. And, enabling something like this, universities are typically not the fastest to adopt, things that are different, but definitely was instrumental in terms of, building this in a way that is a win-win, no conflict of interest, win-win for everybody here.
Yeah, talent pipeline for your respective companies, for all our companies. I think that's a really significant point. I mean, so much of entrepreneurship is rooted in it can be rooted in a rejection of academia. And here Toronto's now a very great example of the opposite of that. This is a talent pipeline and an enablement of innovation, enablement of company building. And would you guys say that's one of Toronto's advantages right now when we think about building next generation companies?
Yeah, I mean, the talent here is incredible, right? Like when we started faculty, I walk in the class and there's Jimmy Ba. Every time you guys train a neural network, you're using his algorithm, right? That's basically the Adam algorithm. Jamie, like literally in that first class that I ever taught at U of T, we came up with like the first mini LLM that was called SkipThought. Jeff gave it a name, all right? That was Jamie that later actually also joined OpenAI. Aidan was in Raquel's class, right? He was just a speaker before. He invented transformers.
We published our first paper, his first paper together when he was an undergrad. Brilliant.
He was already brilliant at the time, right? Chris Madison was part of AlphaGo, right? The first time an algorithm won a world champion in the game of Go. Then obviously the AlexNet, right? The Dropout, which makes, training much more stable. Am I forgetting more stuff? AV, I was talking about data breakthroughs 2012. Actually, Raquel released like the first autonomous driving data set at that time, which really transformed autonomous driving, right? And then a lot of research was enabled by that. It all starts with data, right? And a whole crew of students actually working on that. I'm sure I'm forgetting a lot of it, but basically what I'm saying is that, there's so much talent locally, faculty, students, literally everyone that just looks at, who works here is really impressed, right? And then I guess what I think was a really good move, it was in 2016 when a couple of us decided to form a Vector Institute, really with like maybe two intents, right? One is we noticed brain drain. A lot of these amazing students were going, across the border. So we kind of wanted to create an ecosystem here, and maybe that would, get the companies come to Toronto, which actually did happen later on. And the other one was and this was these big models, but people already anticipated that compute is going to be something we will all need. And obviously, as a faculty that raises, a few $100,000, you cannot afford, to have like a really good funded compute lab. So with Vector, we kind of like wanted to have that resources available and then attract local talent that way. So I think that also became a hub and probably well known. Even today, people actually talk to me about, how Vector is run and so on. So super good.
What do you think? Well said, Sanja. Raquel, what's your view on our advantage right now as an ecosystem?
Yeah. So, I mean, there is a few things that are great about Canada and the reasons why we're here in the first place, right? What personally attracted me to Canada 11 years ago now, I guess, was obviously talent, right? As Sanja talked about, undisputable, incredible ecosystem with particularly U of T, Waterloo, and, respective ecosystems in Montreal and whatnot that were actually, fantastic. Also, we have a set of canonical values that I really appreciate about the country, and I think, this becomes more and more important as a function of time, maybe the times that we live today. Toronto being a very diverse city where, I've been an immigrant for the last 26 years. Let me repeat that, 26 years being an immigrant, okay? And so it's
15.
So for me, it was very important that to join a country where I can be who I am. I don't need to change to actually fit, where I'm supposed to be, but instead, the fact that I come from a different background, I think differently is embraced, and my culture is actually a net positive for the country, right? I think that's, that was very, very important as well. And, I would say that there is a thriving, now as an entrepreneur, there's a thriving VC ecosystem that is also, pretty interesting. I will say as well that there is some opportunities and things that we shouldn't sit, thinking, oh yeah, we are doing everything great, life is going to continue like this way. There is a few things that I think are important. For example, it's great to see Canada trying to have a leadership and having a strategy in AI. We have a new Ministry of AI, etc. But I will argue that if you look at what's happening over there, there is nothing on physical AI. That's a massive miss. Like, this is the revolution that is coming. Canada needs a strategy in physical AI. We talk about our immigration system, a lot of us entrepreneurs, folks in AI, we came from, all sorts of different places. And there is a great opportunity now, given what's happening in South, to actually attract talent, even further, particularly in AI, to Canada. So, but we have an immigration system when oftentimes things get stuck. It takes forever. Where, I will argue that building a program from bringing quickly AI talent, will be a very fantastic boost for the country, as we believe that this is an important, component for us. If you look at entrepreneurship, right? So we need to have many more Shopifys, many more, Coheres, Waabis, etc. Right? So we have a nice kind of like early stage VC community. We have the pension plans once you are into massive revenue to scale further. But we have a whole in between, which is for pre-revenue companies like, that are bold bets, like the Waabis of the world is, how they're very capital intensive. How do you continue kind of supporting such a company so that it doesn't become, mostly US funded, which is the case, unfortunately, right now, of Waabi, for example, right? Is how do we maintain, Canadian companies to keep on being Canadian? We are in times where, tariffs and other things, are making things a little bit harder. For example, for us, all our deployments is in the US, right? We are the only Canadian competitor. Our competitors are US based, right? So it's very important to continue to support to make sure we are not handicapped with respect to, our US competition. And then last bit I will say is that for physical AI, safety critical systems, whether it's self-driving, whether it's humanoid robots, automation of your own warehouses, whatever it is, we need regulations, right? We need to spend more time. The US is so ahead of us on this compared to Canada. So there is an opportunity to act quickly because AI is, is developed very, very quickly so that we can very safely deploy and bring all the benefits that is going to boost our GDP tremendously. That is going to create, incredible opportunities, across the entire country, based on this new industry that is about to create where they have, leaders in the field. So I will say that, these are a few of the things that, where I think there are opportunities that I hope that the new administration kind of thinks about and tries to see how to push this forward.
Yeah, I couldn't agree more. I mean, there's such a premium right now in driving adoption of AI. I agree that there's our regulation is perhaps behind the research, and
we can't deploy in Canada, nowhere. So all our deployment is US based, just because we don't even have the choice, right?
But I think that really requires our ecosystem advocating and understanding what's coming next. A regulation is often driven bottom up, as we know. And so everyone's understanding of what is the frontier of AI, what's happening here in Toronto, how is it going to change your day-to-day life? That is what helps our country get ahead. We can't be reacting to what's happening in other countries when it's happening right here in our own backyard. We have I would argue, an imperative to understand what is at the frontier.
And Mike, I will give us an example. So I was in DC, it was 2 or 3 weeks ago, something like this, where I met with all the regulators, but also with Secretary Duffy. And what we hear from him was, we want a federal, governance, policy, regulatory framework so that, for example, for you in particular, self-driving trucks, you want to deploy them everywhere in the US, right? So that it's actually seamless the way that you can do this. I would love to have those conversations with, with our current administration here in Canada as well.
Yeah. Let's talk about, I want to give the audience a distillation of what's next. So in our last few minutes, Sanja, why don't you help us distill what technology are you most excited about and why?
Yeah, I'm actually quite excited. NVIDIA is already working on it. Our team not quite, but I'm quite excited about the industrial AI. Right now it's called Industry 4. One was about, from manual to automation, steam engines, right? And then there was electricity, computers, and now is smartness, autonomy, robots, AI, right? So much to do there, right? So I think there's Jensen mentioned 5 trillion worth of plant factories being planned to be built in the next few years. 5 trillion, gigantic market. And we need them to be built for the future, right? The future being things are going to be fast-paced, like we talked before, right? We need to have these factories be flexible, automated. There's actually a lot of shortage of employees in certain areas, right? Especially in manufacturing. So, robotics is going to play a major role here. So things like where to build them, how to build them, simulating in advance a piping system and everything such that it's like as optimized as it can be. What you put inside, there's probably thousands of different things that maybe the robots need to perform and have some flexibility around how to perform them. As well as analytics, right? Because you want these robots to be constantly learning. You shouldn't just pre-program them. They should constantly learning in how to actually do things better, right? And some analytics that actually looks at how the factory is operating is this one gigantic brain, and can keep optimizing. So there's so much opportunity there, and we're so at the beginning, I think, of making this happen. And maybe just a really nice example that I was really inspired by. So in the fight for climate change, right, there's now plants that actually capture carbon dioxide from the air, and they try to put it inside Earth, deep inside Earth. So there's plants that actually purposely do that. And per year, I think they capture about 10 million cars worth of exhaust, right? That's actually a lot, and we need to do that better as well. And in order to do that, you actually need to optimize where you're going to build these wells. These wells basically put this carbon deep inside Earth, and what depth you're going to release, and kind of what's the spacing between them. It's kind of a simple setting, right, compared to more general factories. And there's this recent work that using some NVIDIA technology that sped up this simulation almost 1 million times. Yeah. All right, because it wasn't done on GPUs before. And now if you actually implement it efficiently, use AI also for physics simulations, so you can solve these, differential equations or whatever people use in physics much faster. You can do, I think it was 700,000 times, almost 1 million times faster. So what does that mean? I can ask what if questions just so much more efficiently, right? And maybe it can help me scale. So really like a gigantic opportunity here ahead, and too few people working on it. So a great opportunity.
Love it. What about for you, Raquel?
Yes, I will say that, for me, it's all about physical AI robots, right? That, robustifying our supply chain and being able to transport goods faster so that, people that need them can actually utilize them. Making our transportation system to be, much more efficient so that, and also provide transportation for people that today maybe they don't have access to. I think as the population is aging a lot, being able to have robots that can take care of the elderly, for example, I think is very important. I think also, building robots that they can do more of the physical tasks so that we can focus more on using our brains, which is, our advantage, right? To actually do better jobs, I think is very important as well. The good thing about, physical AI is that there is, the time to deploy actually is much larger than in the digital world. So there is, much less risk of labor displacement and people losing jobs, etc. So, some of the studies out there show that you can actually create many more jobs by deploying, this technology like self-driving vehicles, etc. And that, those will be better jobs. And we have time to really form, everybody in order to be able to take, something that will be much better, like truck drivers, for example, instead of going weeks at a time on the road, having no access to bathrooms, for many, many days, showers, it's actually pretty dangerous for women, actually truck drivers. Instead of that, they can actually go home every night to their families, right? It's really about how AI technology and physical AI can really make our lives much better.
Love that. Well, let's, why don't we do something, the three of us right now, like homecoming next year, let's profile the physical AI startups that are founded in the next couple of weeks in Toronto. And if you're a founder in the room who've started one, get in touch with us and we'll make something happen in next homecoming, maybe a session together to increase your exposure. I think it's very clear that time is now to be investing in physical AI. There's so much exciting momentum on the research side, on the application side. And we as an ecosystem have to champion that. So guys, thanks for a great conversation. Looking forward to the next one.
Thank you.